Welcome to Spring LIB.
All right, so this is the answer to chapter 12, number 8 from the Smith Organic Chemistry textbook. And so we are asked to draw the products when starting triacylglycerol A, which I've drawn up here and labeled A, is treated with either excess hydrogen gas and palladium on carbon to give B, or only one equivalent of hydrogen gas and palladium on carbon to give product C. So for ease of looking at this, I've omitted the two other ester side chains, and I've only included the central ester side chain, which is the one with the alkenes, and so which is the only one that's going to react to this hydrogenation reaction. And the key part of this side chain, the part that's going to react, is here. I'm underlining it in red. And so remember, hydrogenation is going to add two hydrogens to an alkene bond and reduce that alkene to an alkane. And so to get the product B with an excess of hydrogen gas, both of these alkenes, because again, remember this number 2 tells us that there are two. And so when treated with excess hydrogen gas, both of these alkenes are reduced. And so we have a completely saturated side chain here, and that's B. And then for C, with only one equivalent of hydrogen gas, only one of the two possible alkenes is going to react. And so you could get this product where you have the number 6 here and the number 7 here. So this would be your first alkene of the two alkenes was hydrogenated and the second was not. And in reality, what you're actually going to get is a mixture of that and of the product where you would get, sorry, let me erase this. So you would get a mixture of that product and of this product where you have nine CH2s here, and you have four CH2s here. And you should get an even mixture of those two, because again, you're only using one equivalent of hydrogen gas, and so only one alkene is going to be hydrogenated. The second part of this question asks us to rank these products in terms of their melting point from low to high. And so the way to arrive at this answer, A, the starting triacylglyceride, has two double bonds. And so it has 4 fewer hydrogens than any of these other two molecules. And so it's going to have the lowest melting point. Molecule C has 1 double bond, so its melting point is going to be intermediate to A and B. And then molecule B, with no double bonds, is the heaviest molecule. It has the most hydrogens, and therefore it's going to have the highest melting point of these 3 molecules.